Hello everyone, welcome back to our lecture series. Today we'll be talking about carboxylic acids nomenclature. So we're looking at the nomenclature of carboxylic acid. Yeah, let's immediately get to it. As usual, I'm going to talk about Gloria Anzaldúa today. I hope I'm saying this name well. She has a quote for us. It says, "I changed myself, I changed the world." This is a simple message. If you can change yourself, if you are disciplined enough to change yourself, you can change the world, you can do anything. Gloria was an American scholar, American, Indian, and indigenous scholar of Chicano studies, feminist theory, queer theory, and the Latinist philosophy. She identifies as a lesbian and queer, and in her work, she told the story of having a fair share of both social and cultural marginalizations during her experiences. So she actually gave us this quote. She was a prolific author and a great scholar. So she said, "I changed myself, I changed the world." So let's take it off immediately from there. Okay, so we now look at our learning objective. In this lecture today, I just have one learning objective to address. So we're going to be using the IUPAC name as usual to name carboxylic acid and then draw their structural formulas. So what it means is that we can have a structure, we write the IUPAC name, or we can have an IUPAC name and then we draw their structural formula. Let's immediately take it off from there. Carboxylic acid. Carboxylic acid are also known as arachidonic acid. If you don't want to call them carboxylic acid, you can call them arachidonic acid. So they are the organic acid. They are organic acids. Unlike an organic acid are known to be what? They're usually known to be weak acid actually. Organic acid are known to be weak acid compared to mineral or inorganic acid that are strong acid that easily ionize. You know, a weak acid is any acid that ionizes partially, that doesn't want to give off a lot of the hydrogen ion. Of course, every acid is known. Remember, every acid is known by giving off hydrogen, or you can say hydronium ion. Do not forget that. Now, so the functional group of carboxylic acid is the carboxyl group. Now, the carboxyl group is made up of the carbonyl carbon and the hydroxyl group. Let's look at it here. Now, the carboxylic functional group is made up of the carbonyl carbon. This is the carbonyl carbon, carbonyl. This is a carbonyl carbon. This carbon is the carbonyl carbon. And the OH group. So it's a combination of two functional groups. A carbonyl carbon, which we get from aldehyde or ketones, and the hydroxyl group combined together to form the whole of this guy, to form this big carboxylic group. Now, you can also write it this way. This is the shortcut. You can write, this is also one of the short form of writing it. This is a short form of writing it. Or it can also be written like this. CO, this is 2, so you can say CO2H, whichever way you write it. So, of course, the carboxyl containing compounds are found abundantly in nature. They are found almost everywhere in nature, including most of the food we eat and the organic product we see every day. So a good example is the lactic acid, which is a product, which is the last product of anaerobic fermentation in carbohydrate breakdown, in glucose metabolism. The citric acid cycle, you find the citric or tricarboxylic cycle, and even the fatty acid, which constitute most of the fatty food we eat every day. So we have common examples here now. In some of these common examples, there are a few ones you need to memorize. You need to memorize acetic acid. Acetic acid is also called ethanoic acid. Acetic means, or ethanoic means 2. So it has 2. So these 2 carbons, and then it has the carboxylic group. Now, the formic acid is just the first one. Met means 1 carbon. That is this formic acid. You need to memorize these 2. So you need to memorize acetic acid, formic acid, and then benzoic acid. Benzoic acid is the parent chain of the aromatic acid. The parent chain of aromatic acid. And again, we covered the aromatic acids when we talked about the unsaturated hydrocarbons. Okay, so the aromatics, just remember that. So you need to memorize these ones, both their IUPAC names and their common names. You know, this is the common name. You need to know both their common names, and this is also common name and their IUPAC names. Okay, let's take it off from there. So fatty acid, of course, are carboxylic acid with long hydrocarbon chains. They have very long hydrocarbon chains. And because those hydrocarbon chains are very nonpolar, they're usually very insoluble in water. So these hydrocarbon chains are generally between 12 to 20 carbons. They were first isolated from natural fat, and that gives them their name fatty acid. That's what we call them, fatty acid. They are usually even numbered, and they are the digestive products of the lipid. Of course, when the lipases in the lipases, when the lipases break down lipids, they convert them to fatty acids. They convert them to fatty acid and glycerols. They convert them to fatty acids plus glycerol. So that's why I said they are what? The digestive products of the lipid. And they are usually exclusively known by their common names. So I have a good example here. This is C14. So if you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So of course, remember, I'm going to use a different color. This is the carboxylic acid group. And this is, now this carboxylic acid group is actually a polar functional group. But you see the rest of this hydrocarbon chain is usually non-polar. But we're still going to talk about this much more later. So this is myristic acid. Myristic acid is a fatty acid that has what? 14 carbons. Now let's go to the nomenclature, which is the main cross of the matter that we need to deal in this class. That is the main cross of the matter that we need to deal with in this class, is to talk about their nomenclature. Now let's look at the rules. As I did in other class, I always talk about the rules first. Now in the rules, the rules include about four rules. Let's take it one after the other. Now, as usual, like in every IUPAC rule, the longest chain that contains the what? The carboxylic group is identified and numbered. Now, the numbering must begin in the carboxyl carbon. The carboxyl carbon is the one that has the carbonyl carbon and then the OH group. So it must usually, because it is usually number 1. Usually number 1 carbon. It is usually the number 1 carbon. Now, what change are we going to make? The final Ne from the end of a hydrocarbon name is dropped and is replaced by OIC. OIC is added, followed by the word acid. Each of them must end by the word acid, no matter where, because they are organic acid. Then we can now name other attached groups. Other attached groups are identified and named according to, particularly in alphabetical, remember that, in alphabetical order. In alphabetical order. Now, I put this caveat here. It says, since carboxylic carbon is usually carbon number 1, there is no need to give it a number in nomenclature. No need to name them, because they are what? Terminal compound. We call them terminal compound because the carbonyl carbon, just like the aldehyde, we start naming it from that carboxylic carbon. So the terminal compound, no need to say 1, no need to put a number on that functional group, which is the carboxylic functional group, because it can only exist at the end of the chain. Let us now take these examples immediately. In our first reflection here, let's see what is going on. In the first reflection question, it says, name the following carboxylic acid. Like I said, as usual, we're going to identify the longest chain. And then after that, we're going to name it from the carboxylic group, and then we're going to identify the attachment. Let's look at this. There is 1, 2, 3, 4. It's 1, 2, 3, 4. So it is the longest chain is from here is 1, 2, 3, 4. What this tells us is that this is an attachment. And this attachment is actually what? The methyl group. So now what do? We're going to, first of all, as usual, in IUPAC name, you have to start with the attachment. So it's going to be, it's located in carbon number 3. So this is going to be 3 methyl. 3 methyl. Remember, we don't need to say 1 carboxylic acid because it's always carbon number 1. So what are we going to do? We have to just say. So the longest chain here is what? 4. And 4 means but. 4 means but. So it's going to be but. Remember, we are supposed to say butane. But in this case, what are we going to say? We're going to say, remember, you're supposed to say butane. But you're going to remove this E. So I'm going to remove that E. I just want to show you how it's done. You're going to remove this key. And you're going to put OIC. So it's going to be, you're going to say OIC. Then you put acid. So this is 3-methyl butanoic acid. That is how we name this compound. 3-methyl butanoic acid. Now we go to this one. To name this one quickly, I turned it. It shouldn't confuse you. Always know that this is going to be carbon number 1. So this is 1, 2, 3, 4, 5, and 6. Now we have 6 as the longest chain. So this is a hexanoic acid. That's what it means. We need to locate the attachment. What is the attachment? Bromine is the attachment. So it's bromo. We're going to call it bromo. It's attached at this point. So it's going to be in carbon number 4. So it's going to be 4 bromo. No, we don't, because there's no number again. So we don't have to put dash. So it's going to be 4 bromo hexanoic acid. The longest chain is hexanoic acid. So this is going to be hexanoic acid. Oh no, I put that. I need to separate it usually. Hexanoic acid. That is how we name that. We go to the last one I have here. Again, name the longest chain first. If you count from here, 1, 2, 3, 4, 5, 6, 7. That is a long chain. But what do? You find out that you are neglecting, you are not recognizing all the attachment. So it has to be that attachment that has the longest chain and all the attachment included. So what are we going to do? We're going to count it from here. 1, 2, 3, 4, 5, 6, 7. So you see, this is 1, 2, 3, 4, 5, 6, 7. It's a long chain, but this is also a long chain. But this one doesn't have other attachment like the fluoro. So you have to go with this one. So this is what? Heptanoic acid. That will be the longest chain. So what do we do next? We identify the attachment and then alphabetize them. What are the attachment? This is fluoro. Remember? Now what is this? This is sec-butyl. This is sec-butyl. Sec-butyl. Remember, the sec doesn't count. We start counting from the B here. So this is B. This is F. This is B. Do we have any other attachment? We do not. We just have only 2 attachments. So which will come first? Sec-butyl. So to name this now, what are we going to say? We're going to say is no carbon number 4. So we're going to say 4 sec-butyl. 4 sec-butyl. Where is this located? In carbon number 5. 5 fluoro. Remember, it is fluoro. Then the longest chain is what? The longest chain, remember, is heptanoic acid. So it can't complete it. I'll put it here. So this is going to be heptanoic acid. That is how we name this. All right, we go to the next one. Now let's talk about aromatic acids. Aromatic acids are named. I already said about this when I gave you some of them to memorize. Aromatic acids and aromatic acid names are derived from their parent compound. Their parent compound is what? The parent compound is benzoic acid. So I already said that. All of them are derived from it. So this is the parent compound. Benzoic acid is their parent, is their grandfather. All of them must be derived from it. Now, and again, we covered this aromatic acid in unsaturated hydrocarbon module. So, but I'm just going to name a few. So if you look at this one now, this is benzoic acid. There's attachment in carbon number 3. Usually this is carbon number 1. So if you count the 1, 2, 3, if you count this with 1, 2, 3, 4, this becomes 5. So we must count 1, 2, 3. 1, 2, 3. So what it means, this is methyl group in carbon number 3. So to name it, we say 3-methyl benzoic acid. That's how we name this. Or we use the what? The other OMP that represents the Greek attachment. OMP. If it is carbon number 2, it becomes O. If it is in carbon number 3, it becomes meta or M. If it's in carbon number 4, it becomes para or P. So here is in carbon number 3. So this is going to be, what are we going to call it? We're going to say M-methyl benzoic acid. Oh, I think I'm missing L in that methyl there. So there is an L here. Don't forget that. No, wait, that didn't go well. M-methyl, there should be L here. Okay, the L doesn't want to enter, but just know that I'm missing it. So let me write M methyl benzoic acid. That's how you name that. All right, so we go to the next one. In the next one, here now, of course, you cannot use the OMP when you have more than 2 attachments, like we have here. So here, we have methyl group, we have bromine group here. But what would determine where to count from cannot be this way, because this is M, this is B. So we're going to count 1, 2, 3, 4, 5, 6. So that's why this is going to be 3 bromo. This is carbon number 3, bromine here. Then 5 methyl benzoic acid. And again, all of them were named. You see, all of them ended in benzoic acid, because they are all derived from this guy. Do not forget that. Let's take some more. Okay, now let's talk about those organic acids or carboxylic acid with more than 1 COOH, with more than 1 carboxylic group. So to name the dicarboxylic acid, we add the suffix dioic. Remember, we just say oic. In this case, there are 2. We say dioic to the name of the parent alkane that contains both the carboxylic groups. So what it means is that we're going to have the ANE will become ANE dioic acid. In this case, we're going to leave the E here because this is a D. That's why this is a D. So this is a vowel, this is a consonant. That's why we're going to leave it. So the numbers of the carboxylic acid, of course, are not indicated as usual because they are always at the end of the chain. So let's take a good example. So this one, this is carbon 1, 2. So in this 1, 2, this will be ethane 2. Et means 2. Remember, et means 2. So this is ethane dioic acid. And the old name, not the old, let's say the common name. The common name is oxalic acid. That's the common name. The same thing goes here. If you count this one, 1, 2, 3, 4. This is butane. Remember, you see the whole name was given here, dioic acid. And the common name is succinic acid. So this is how we name this one. So now we're going to do a bunch of other reflection questions here. Now, feel free as you're watching this video to always pause this, try out these problems yourself, and always come back to check for comprehension. Okay? So this, as you're watching this video, this class is asynchronous. Pause the video, try out this question for yourself, and then come back and see if you got them correctly. So let's take this. It says, name the following carboxylic acid again. As usual, I'm going to be applying the rules directly and naming them. Of course, I'll start counting on naming the carbons from the carboxylic group. And here, this is it. I'll give this number 1. I'll count 1, 2, 3, 4, 5, 6. 1, 2, 3. So the longest chain is this. So this 1, 2, 3, 4, 5, and 6. 6 is the longest chain. So this is hexanoic acid. But I have some attachment. There's an attachment at this point, which is bromo, and there's methyl group here. B comes first before M. So what are we going to say? We're going to say 5 bromine is 5 bromo, then 2 methyl, that's methyl group, 2 methyl, the longest chain is what? Hexanoic acid. This is hexanoic acid. That's how we name this. So let me just call this A. Then let me go to B. For the B, to name this one again, you see this now has 2, this is a dicarboxylic acid because it does have 2 carboxylic groups in both ends. If I come from here, 1, 2, 3, 4. If I come from here, it gives me 1, 2, 3. If I come from here now, this becomes number 3. If I come from here, this becomes number 2. So I'm going to favor counting from 1, 2, 3, and 4. So since this is 4, the longest chain is butane dioic acid. It has 2, remember, don't forget, it has 2 carboxylic acid on both ends. Then counting this way gives this number 2, but counting from here gives it number 3. So this one will be the preferable counting for us. Now, what do I now do? So we start. What functional group is this? This functional group is tet-butyl. Tet-butyl. So let's start. Where is it located? The carbon number 2. So it's going to be 2 tet-butyl. 2 tet-butyl. Then this is 4. The longest chain is butane dioic acid. So we say butane di. oic acid. That is how we name this. Then we go to the next one. In this one again, we count the longest chain, starting from here. So this is going to be 1, 2, 3, 4, 5. The longest chain is 5. And then we have attachment. This attachment, remember, when there's carboxylic acid, we're going to count this one as an attachment. This is an amino. And this is going to be fluoro. This is fluoro. So having done that, what do? We name it. So A comes before F. So this is going to be in carbon number 4. So this will be 4 amino 5. This is carbon number 5. 5 fluoro. 5 fluoro. The longest chain is pentanoic acid. So this is 5. Pentanoic acid. That is how we name this. And then we go to this one. Remember, this is F. Let me make sure it's clear. Yeah. We go to this one. So this one has no attachment. It's 1, 2, 3, 4. Oh, this is easy. It is just no attachment. So this is going to be 4. Butane is 4. So it's going to be butanoic acid. That's exactly what we have here. I have another reflection question. Again, you can pause for a few moments and try to do this yourself and let that come back to them. All right? So let's see what happens. Again, say name the following. To name them again, this has 2 carboxylic acid groups. 1, 2, 3. No attachment. So this is propane dioic acid. There's no attachment. So this is going to give us 3 is prop. So this is propane. Because there are 2 of them here, 2 carboxylic groups. We're going to say dioic acid. Propane dioic acid. And then, okay, so let me call this A. Okay, let me name this one before I go to these other ones here. For this one, so to name this, now let's count. This is the carboxylic group. So we say 1, 2, 3, 4, 5. This could be 6, 5, 6, but this is not the longest chain. If you look this, we can say 1, 2, 3, 4, 5, 6, 7. So 7 is the longest chain. Every other thing will be an attachment. So what are the attachments? Let's identify them. NO2 means nitro. This is fluoro. This is metal. Now we're going to alphabetize all of them. There are 3 attachments. So which will come first? Which will come first? F will come first, fluoro. So this is going to be, let me put it here, 4 fluoro. What else? After F, which one comes? This M and N. M comes first. So this is going to be in carbon number 5, metal group. 5 metal. Another dash. I don't have space. I will get it to the second row here. Then we now get the last one. Nitro is in carbon number 2. 2 nitro. And the longest chain is 7. Remember, 7 means heptanoic acid. So this is going to be heptanoic acid. That is how we name this. All right, we now go to these 2 aromatic groups. Let's see. Now, again, we identify the longest chain. This is our carboxylic group here. So we're going to start naming from this carbon. This is 1, 2, 3, 4, 5. Oh, this is 5. This is pentanoic acid. It only has 1 carboxylic group. And then, so what it means, this is an attachment. Now, what the attachment is this? Remember, this attachment is phenyl. This is the phenyl. When benzene ring is an attachment, we call it phenyl. And this is what? Metal. So M and P, which one comes first? That has to be M. So it's going to be, and it's in carbon number 4. So this is going to be 4 metal. Then, where's the phenyl group is located in carbon number 3. 3 phenyl. And the longest chain is what? 1, 2, 3, 4, 5. Like we said, it's going to be pentanoic acid. Pentanoic acid. That is how we name this. And then we go to this last one. Again, this is just the benzyl ring. Everything is on the benzyl ring. So this must be named as benzoic acid. So let's count. What attachment? Let's look at attachment first. This attachment is sec-butyl. And this is methyl. What does that tell us? What it tells us is that now we're going to count from this is B and this is M. So we're going to be counting from this. Remember, the sec here doesn't count because it's a prefix. You have to start counting from B. So now we're going to label. So B here is from M. So we're going to say 1, 2, 3, 4, 5, 6. So it's going to be 3 sec-butyl. So here we're going to name it as 3 sec-butyl, then 5 methyl benzoic acid. That is how we name this. I have another one too for you here. I have another beautiful one here. In this case, we've been doing it, having the structure and naming it. In this case, we're going to have the name, the IUPAC name. We're going to draw the structure. Now, in doing this, like I've always done in this series, the first thing you need to do, you want to get the longest chain in this reflection 4. So it says 7 amino, 5 bromo, 3 hydroxy heptanoic acid. So 7. So you can count from anywhere. So I'm going to pull my distance from here, my carboxylic group. So I'm going to start from here. So if I start from here and put it here, so if this is my carboxylic acid, if I do it this way, you can do it any way you want. If I do it this way, and this is my carboxylic group. So I'm going to say 1. I'm going to make that much better. So I'm going to say 1, 2. Oh, will I have enough space for the, okay, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7. Okay, that's 7. That's 7. Heptanoic acid. So let's now put the attachment. That's heptanoic acid. So let me just label it. 1, 2, 3, 4, 5, 6, 7. Then let's begin to put the attachment. It says 7 amino. Amino is in carbon number 7. So it's going to be here. NH2. Bromine is in carbon number 5. 5 bromo. 5 bromo. This is carbon number 5 here. So there's going to be Br here. And then 3 hydroxy. Hydroxy group is in carbon number 3. So this is how you draw that from the IUPAC nomenclature. So that is how you draw that. So it's always important when you are drawing this, first of all, draw the longest chain, number it yourself, and now begin to add the attachment. So we're going to do with this one again. This one is hexanoic acid again. Let me put it there. So you can start from anywhere. It doesn't matter. Okay, I'm going to change this one and start from other place. So I'm going to start from here now. So I'm going to say, if this is my OH group, and then this is my O, so I'm going to say 1, 2, 3, 4, 5, 6. So let me number it then. 1, 2, 3, 4, 5. Oh, that's long. 1, 2, 3, 4, 5, 6. You see why it's good to number it? So it's too long. What it means, I'm going to remove one of them. So because it is 6, it's hexanoic. Look at it. It is hexanoic acid. That's what I want. 1, 2, 3, 4, 5, 6. Then I'll now start putting 2 amino. Amino is in carbon number 2. So I'm going to put my amino group here. 2 amino. 4 iodine. My iodine is in carbon number 4. So I'm going to just move this by the side. So I'm going to say my iodine is here. 4 iodo. 2 amino. 2 amino. 4 iodo. 6 nitro. My nitro is in carbon number 6. So what it means, I'm going to extend it from here and add NO2. So this is 2 amino, 4 iodo, 6 nitro hexanoic acid. 1, 2, 3, 4, 5, 6. Remember, this is the shortcut for phenyl. This is the short. So the phenyl group is in carbon number 5. This is the shortcut for phenyl group. So, and that is how we do that problem. Then the last thing we're going to talk about, not very important, but it's good just to chip it in, is common nomenclature. Now, for common names, the Greek letters of alpha, beta, gamma are used. This is the Greek alphabet are used to denote the positions of the attachment. Or the position, the position of the attachment or the substituent. If you don't want this attachment, you can say a substituent. Now, this counting actually begins after the carboxylic carbon. Look at the old name. In the IUPAC name, we count here as 1, 2, 3, 4. In the old name, this is not counted. You start counting your alpha from a carbon after the carbonic carbon, after the carboxylic carbon. So this is alpha is the second carbon, beta is the third carbon, gamma is the fourth carbon. So if we take this as an example now, look at this example now. In the true IUPAC nomenclature, if you want to do IUPAC, this is carbon number 1, this is 2, this is 3, and this is 4. So what it means, in IUPAC nomenclature, this is amino group. We're going to say 3-amino butanoic acid. So look at the IUPAC name. So the IUPAC name here is going to be 3-amino, because it is attached to carbon number 3, and this has only one carboxylic group. So this is 3-amino butanoic acid. But in the common name, what do? We're going to start counting from here. This is alpha, beta, and gamma. So this particular amino group is attached at the beta group. So at the beta. So what are we going to say? We're going to say beta amino butyric acid. In the old nomenclature, you don't say you won't say butanoic acid. Instead of saying butanoic acid, you say butyric acid. So it's going to be beta amino butyric acid. So that would be the common name, or what some people might call the old nomenclature. So I'm going to use this to show you. So this is the common or the old name, whereas this is the IUPAC name. However, I'm not going to test you based on this common name at all, but it's important for you to know, because as you begin to go into the real world tomorrow to get jobs and begin to practice your profession, you find out that these common names or old names still make their ways into the daily lives and what you use every day in the hospital and in industry. And having said that, we've come to the end of this lecture. Thank you once again for listening, and have a wonderful day ahead. Bye.